Okay, so today we are going to solve educational code forces around 190, problem B. So in this problem, you are given a string consisting of digits from 1 to 4, and the problem statement says that the string is beautiful. The string is beautiful if it's impossible to select some of its elements and write them out in the same order, which is a multiple of 4. For example, these are beautiful and these are not. An empty string is beautiful. We need to calculate the minimum possible number of elements in the string we should remove in order to make it beautiful. So what does it mean? Let's see. So we have a string, right? Let's say, let's take an example. So we are given a string. We are given this number, which is in the form of a string. So S equals to this. Now, the string is beautiful if we can choose a number which is divisible by 4. Now, for this string, let's say we choose this. So this is 4. 4 is divisible by 4. So this string is not beautiful. Let's take another example. In this string, we can choose this 2. It makes 32. Or we can choose this 2. It's 12. In both cases, they are divisible by 4. So we can find a sequence of numbers. We can find a sequence of numbers which together form another number which is divisible by 4. So in the string, we can choose such numbers cannot be called beautiful string. So this string and this string are not beautiful. On the other hand, let's take this example where this string, or this string, all the strings, we cannot choose any sequence of numbers such that the number formed by the digits we choose is divisible by 4. Let's take an example. In this string, no amount of 2 we choose, no matter how many 2 we choose from this string, this it's never divisible by 4. Why? Because uh, this, for example, 2 to 2, let's say there are some 2 to 2 to 2 is divisible by 2. If divided by 2, it becomes actually 1, 1, 1, and so on. And to make this divisible by 4, this has to be divisible by 2, and it's not possible. So this type of number cannot be divisible by 4. And of course, the odd number is not divisible by 4. So we can choose actually some sequence of 2, then some 3, and this can be divisible by 4. And same goes for some sequence only consisting of 3. This also cannot be divisible by 4. So what do we do? In this problem, we are told to let's say we have this string, so let's write it again. 3 2 4 4 and 1 2 3. We have to make this string so that we have to transform this string to another string by removing some elements so that the transform string is beautiful. This string is beautiful, and beautiful means we can't find any sequence that can be divisible by 4. So all the strings here are beautiful because all of these strings are beautiful, but this string is not, because we can choose all these numbers, also not this string. So let's take a smaller example. 3 1 2 3. So from this string, uh, let's remove some numbers. This number, let's remove this and this. So the remaining string is 23 to 3. Now we can choose, we can make a number. We can make 2, we can make 3 from this string, or we can make 23. None of them is divisible by 4. So this is beautiful, and we needed to remove 2 elements to make this happen. So we are told to remove the minimum possible number of elements in order to make it beautiful. So since we have to remove the minimum possible number of elements, we can make an observation, which is remove minimum elements is the same as keeping maximum elements, right? If you remove minimum number of elements, then you you're basically keeping maximum number of elements. So it's sometimes easier to calculate what is the max number of elements you can keep and subtract n minus max to find the minimum number of elements. Okay, why we do this? Why we do this and not this? Let's see. Let's see what kind of string we cannot take. If a string contains 4, let's say this is our string, and somewhere in the string we have 4. We have to remove this 4 because 4 is divisible by 4. Another example, in another case would be somewhere in the string we have a 3, and later somewhere we have a 2. So if we choose this 2, 32 is divisible by 4. So we either need to remove this one or this one, but we actually don't know which one to remove. Removing which one would give us the best possible answer. Same goes for, let's say we have somewhere 1, and then somewhere later we have 2. So at 12, if we choose this 2, we get 12, which is also divisible by 4. So only, so 1 cannot be before 2, and 3 also cannot be before 2, and there cannot be any 4. So this actually implies that the only format of string we are allowed to have, but after transforming, is a string of this format. All the 2's are before, and then we have 1 3 3 1, or some 1 and some 3. But this later part would not contain any 2, no 2. And the previous part has some number of 2, some number of 2. Possibly 0, possibly no 2, like 3, only 3, 3, like this. So this is our only desired format of the transform string. So we just need to calculate what is the longest string of this format we can get from our original string S. How do we do it? Notice that all the 2's are at the beginning or at the prefix, and all the 3 and 1's are at the suffix. So the thing we can do is take the prefix sum for the number of 2's and take the suffix sum for number of 3's. So let's say this is our entire string, and we are at current index I. And by prefix sum, we have calculated how many 2's in this part, and using suffix sum. So this is actually prefix of I, and this is actually suffix of I, which is count of 1 plus count of 3 in after I. If we know to calculate suffix I and prefix I, so for each I, we are getting this part, length of this part, and with suffix I, we are getting length of this part. If we add them together, we actually get a particular sequence of 2, 2, 2, then 1, 3, 1, 2, 3, like this, something. We actually get something like that. And for each I, we are going to get some length. So for each I, we are going to have some length, and we simply take the maximum of this length. And finally, we subtract max from our n. Clear? That is our final answer. That is the minimum number of elements we need to remove. Now let's look at the code. So here we initialized our result with infinity, and then we calculated prefix sum for 2, and then suffix sum for 1 and 3. Then we calculated our max for the index, which we get max. We got our max, and then our final answer is n minus max. Pretty simple. That's it. That's the solution. In the next video, we're going to discuss column C. Until later, see you.